Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and very good morning, good day to you. So today I'm going to show to you, I'm going to share with you on how to do some of the spatial analysis in QGIS. So this example is only for vector. This lab exercise is only for vector analysis. Okay. So firstly, if you open all the data that I already to you previously, so we have all this data. We have road. We have also all the building inside UTM. We have also lake and then all the field in UTM. So today I'm going to show you how to do some of the analysis, not all, but some of the analysis that that is important, okay, that always been used in GIS. Alright, so before that I'm going to delete all the layer that have been done previously. Alright, so this is data. So for vector and raster, for spatial data analysis in QGIS, we have vector and raster over here. If you click over that, up in here, we have vector and raster. So vector is all the analysis for vector, and raster is all the analysis for raster. So previously we already discussed on the raster analysis georeferencer, where we put our map based on the reference system, and then we put into our view. Okay, so this is the previous output from the previous lab exercise. So we have shifted the map from the unknown coordinate system to the known coordinate system, which is the RSO. Alright, so that's the first thing. Okay, raster we already discussed, and then under raster analysis we also have raster calculator, and then we can also align the raster. Okay, other than that we have some other analysis such as aspect, field node data, grid, hill shade, near black, proximity, roughness, sieve, slope, topographic position index, and terrain ruggedness index. So some of these analysis I already cover in our class discussion, spatial data analysis. And then beside that, we in raster we also have projection analysis. We can assign the projection, or we can extract the projection, and also we can warp or we going to reproject back the raster data. And then we have also build virtual raster, merge, and so on. Extraction, we have clip raster. We clip certain data only, create raster by mask layer, and also we can create a contour based on the raster data. And then lastly we have conversion, PCT to RGB, polygonarize, rasterize, RGB to PCT, and also we can translate we can convert from other data to another format. So in GIS, the data that have coordinate is TIFF data, right? That we already done previously. For this data, we already save it as a TIFF data format. Okay, that is some explanation on the raster analysis. So for vector, we have geoprocessing tools. So we can do all the buffer, clip, correct hull, differences, dissolve, intersection, symmetrical difference, union, and eliminate selected polygon. So this is some of the simple analysis. Though we're not going to cover all, we maybe cover a little bit on buffer, clip, and dissolve, and some maybe intersection and union. Okay, other than that, we have geometry tool. We can do centroid. We can get the center point of a polygon. Okay, we can collect geometries, extract vertices, and so on. Alright, so Voronoi also already discussed a little bit on the topic discussion. So we also have, okay, extract vertices, multi-part to single part, polygon to line. So we have polygon, we're going to make a line from that, and then we can simplify the line. For example, our road, okay, the curve is too much, and then you can simplify, or in another term is generalize the line. And then we can also check validity, and then we can do the Laune triangulation. We can also densify by count, and then add geometry attribute lines to polygon. If you have line, like close line, you want to make a new polygon, you can also do over here. Other than that, we have the third tools is the research tool. We can create grid, select by location, extract layer extend, random point in extend, random point in layer bound, random point inside polygon, random selection within subset, and regular point. And then we also have analysis tool if you want to do some line intersection. Mean coordinate, we want to see what the mean coordinate for all the data, and then basic statistic for field, count point in polygon, and then distance matrix, list unique value, nearest neighborhood analysis, and some line length. And so we also have data management tool for merge vector layer. Okay, we're going to overlay all the vector layer into certain data, but we do not use this. And then we can reproject layer, okay, create spatial index, join attribute by location, and lastly we can split vector layer. Okay, so what I'm going to share with you today is the vector analysis. So firstly, I will discuss or will show to you how to make a buffer. So this is if you click the buffer analysis, this is the window that will come out. So they have two tabs over here. The first one is parameter, the second one is log. Okay, the log is all the analysis that will be done behind the scene. We will show this over here. I will show you to you later. And then this is the parameter. Okay, what is the data we're going to do some buffer and so on. Okay, so for example, this one we take jalan, okay, or the road. Okay, and then try to put a distance of 15 meters, 15. Or make sure you select the correct unit, meter, not kilometer, feet, miles, or yard. So click meter. Then segment, just leave it as a 5. And then end cap style, we have 3 type: round, flat, and square. So this for this the first one, okay, select flat. Okay, the join style means that all the line for the road is segmentized, so they have 1 or 2 or maybe 5, maybe 10 segment for one line. Okay, I will show you what they mean by that. Okay, for example, we select this road. Okay, sorry, need to activate this road first. Okay, this is one segment, this one road, but they have 2 segment over here, 1 segment and then the 2 second segment. Another example is if you select this one, okay, this only one road, 1 segment, so it's okay. Okay, this one is they have 2 segment. Okay, this road they have so many segment. So the join of this segment and this segment, the buffer, it will give different type, different style. Okay, try to just leave to round, then meter limit just leave it to 2, and then dissolve result. Okay, this is important. Later on we will see dissolve and undissolve result. Okay, and then buffer, we can to create a layer. So create over here, and then save the file. So we can save it as a jalan 15 meters. So we have joints end flat, the end is flat, and also will not dissolve. Okay, I will show to you what happened when we dissolve flat end. Okay, alright, save. Okay, oh sorry, I need to find the location first. Sorry, this is a different location. MGHG 1114 lab exercise 4. Okay, rename back jalan JLN 15 meters. flat end. Okay, this one is not dissolve, so later on we will add a dissolve over here. Okay, save. Alright, so after that we recheck back. Okay, the input layer is jalan, distance is 15 meters, segment 5 and cap flat around 2 meters, and location. Okay, click run. Okay, as I told you, the log will show you all the behind the analysis. Okay, if we close this, okay, this is what I told you previously. Okay, sorry. Okay, this is the buffer. Okay, so we not dissolve between the buffer, so this is means that the flat area. Okay, we can see where's the, okay, over here we select flat, so the vector buffer we select flat over here, the end cap style is flat, so you just end like that. Okay, I will show you if you use square and round after this. Okay, that's the meaning of the first one is the flat, and also the not dissolve. Okay, second analysis, not second analysis, we do the same analysis. Okay, for jalan also, but we change the join style. No, sorry, we select dissolve result. Okay, and then we save is as, lastly we have dissolve. Okay, we select flat end and then we select dissolve. Alright, so we see what we happen to our analysis or our data. Okay, look over here, there's the difference. Okay, if you select dissolve, okay, but the end still flat, so what will happen, they have some segment that is not connected over here. Okay, right, maybe not over here. Okay, that's the buffer, but because we selected flat, so it's not connected between this. So this is important when you select a good type of buffering. Okay, again we try to make the same analysis buffer, but we change a little bit. Select jalan, where's jalan, and then the distance is 15 meters, and cap style we select round this time, and then we create dissolve. Okay, join style we also select round. Okay, and then dissolve. Alright, we change it into jalan 15 meters round and dissolve. Okay, so if we see over here, alright, so where's the road? You cannot see it. You change the color into maybe green color. Alright, so we can see the difference. So the end is round, much better, and then all the segment is don't have any issue on like previous one. Okay, if we close this one, look, there's the difference. They have some certain, if you not selected round at the end or the segment, and if you select, they will be give more smooth buffer polygon. Alright, okay, that's the first analysis, which is buffer. So the second analysis that we're going to show you, still a vector analysis. Try to select clip. Okay, click. Okay, before I forgot, the second analysis we try to see dissolve first. So dissolve. Alright, if you remember the first one, I will show the data first. Close this one. Okay, this is the data, buffer data, the first one that is not dissolved. Remember when we do the analysis, okay, we not dissolve the end or the segment, continuation between segment. Okay, so we're going to dissolve this and then try to see what will happen. So try to select dissolve. Okay, we select the jalan 15 meter flat end. So we're going to dissolve this and then we create save a file, or you can just leave it as a temporary file, create a temporary file so it will not save. Okay, but I'm going to save it for the purpose of this this assessment flat end. So we doing the dissolve DIS dissolve analysis. Okay, so from this one to we're going to dissolve. Alright, so let's run. Alright, so what will happen is they will give you all the dissolve, the connected. So from this data, they will dissolve all the segmentation, all the between polygon and polygon. It will dissolve all the boundaries. Okay, that's a simple one lah. So we already discussed a little bit on dissolve. You can try with another data if you have it. Okay, so the next one will teach you, will show to you how to do clip. So means clip is which one? This one. Okay, so this is data we want going to see which data or which collage area is under or overlay, can be overlay into the buffer, 15 meter buffer. So the example, how we going to show it? Collage. No. I try to drag collage. So this is some other building that is in 15 meter area from the road. Okay. So this one is clip. So you select 15 meter flat, not flat, and round and dissolve. And also, the input layer is building. Sorry, collage. Try to find collage. Okay, and then you select this one is jalan round and dissolve. Okay, you remember the round end, the end is round, and also we dissolve it. Okay, save the file, collage clip 15 meter from jalan. Okay, try to run it. Okay, it will create a new data. Okay, try to put it over here. Look over here. This is when we clip the data. Okay, this is the area of that building that is 15 meter from the main road, or from the road, not the main road, from the road. Okay, so that's the usage of clip. Another example, if you have watershed maybe, or maybe the boundaries of that area, so you want to see how many road is only on the area. For example, this data has been clipped, all the data that's in UTM only, so we can have the UTM boundary, and then we have road line, all the road line for the whole nation, and then we clip only for this analysis. So I clip this one. So this is the example of clipping the road or the line analysis. Okay, this is the clip. Alright, so we already discussed on the buffer, clip, and dissolve. Okay, and then that we can try by yourself. So the next one I'm going to share with you on the Centroid. Centroid, we're going to see what the center of of the polygon. So the example, we try to find college, okay, and then we save it, Centroid college, okay, and then we run, test run, close. Okay, what will happen is over here. Alright, okay, I try to close first, all the unrelated. Okay, this is the center of each building in college area. That is a college building. So example over here, this is simple one lah. You can find center from is n, but if you have this one, quite complicated. So this is the center of this building. Okay, another building, this one. Okay. The center of this, the whole building is outside of the building. So because we take the analysis, right, we selected like that. Okay, another example, this is a very complex building or polygon. They will take a center of this polygon. Alright, okay, I think that's all what I'm going to show to you today on this lab exercise 4. So from there, you can do some simple analysis. This is the example of the, maybe is later on in the future, electrical asset management going to develop a new electrical line inside UTM. So what you're going to do is you take this line, I will upload later on in e-learning. Take this line, okay, make a buffer, and then try to find which building is inside that buffer area. So you will have around certain type of buffer. I will give the exercise in e-learning later on. So you need to find how many building is affected by this line. Okay, all right. So I think that's all for today's exercise. So hopefully you can understand, and thank you very much. Assalamualaikum and good day.